Okay, so here we are talking about acid-base neutralization. We already established that an acid reacted with a base yields a salt plus H plus OH minus. Very simple. These are neutralization reactions because we said the pH comes down to 7, which means the hydrogen ion concentration is 1.0 times 10 to the negative 7. And then we also said that if we have an acid, it's a hydrogen ion. If we have a base, it's a hydroxide ion. H plus OH. Collisions, 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 collisions make H plus OH minus. That's water. Neutral. By the way, the reverse of this is called hydrolysis. Okay, so let's see how this is a double replacement reaction. So let's review. What were the types of chemical reactions? Synthesis, decomposition, single replacement, double replacement, and combustion. And we can't forget our reference tables. Double replace. Here we go. HCl. Look on your reference table. Everybody look on your reference table, including me. If we go to the chemistry reference tables, remember these? If we go to the chemistry reference tables and we go to table K, table K. Remember table K? HCl, AQ, hydrochloric acid. But do you remember that HCl is an aqueous? Is that a homogeneous mixture? Yes. Is that a solution? Yes. So let's draw it. You know, this is for all my biggest fans out there. Water is a polar covalent solvent. And even Duran knows, shout out to Duran, oxygen feels highly electronegative. So this is the negative end. Hydrogen feels partially positive. So this is the positive end. This is a polar molecule with a polar bond. Dot, 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 dot. What intermolecular force holds these two molecules together? Hydrogen. Come on, I can hear you. Bonding. This is an IMF, an intermolecular force. For all my pre-med majors out there, for all the people out there, look at all those healthcare workers who we love so much, these doctors and these scientists putting their lives on the line to help fight this virus and this pandemic. We need those kinds of minds, ladies and gentlemen. So we have the hydrogen bonding. If I take hydrochloric acid and it follows the Arrhenius theory, which it does, isn't it true that the H plus splits off and the Cl minus splits off? So there's your definition. Let's see if the pencil shows. The hydrogen ion is yielded. The hydrogen ion is formed in solution. Acid. Okay? So where is the H plus going to go? They told us this is an AQ. They told us this is a homogeneous mixture. This is a solution of acid in water, hydrochloric acid in water. So where's the H plus going to go? Opposites attract, opposites attract, opposites attract. H plus. Where is the Cl minus going to go? Opposites attract. Hydrogen ion is a positive species. It goes with the oxygen. Chloride ion is a negative species. It goes with the hydrogen. So now we're in a position where the ions are free. Ions free. If the ions are free, is this an electrolyte? Yes. Is this a homogeneous mixture? Yes. But if these ions are free moving, can this conduct electricity? Yes, it's an electrolyte. That's the justification why acids, bases, and salts are electrolytes. Acids, bases, and salts are electrolytes. They are solutions that conduct electricity. So now, let's talk about this double replacement reaction. And we're going to assume at our level that the ions are always free moving. We're always going to have what we call 100% ionization of the acid. And everything on table K, just to go back, everything on table K does this. It splits. You have to remember H, 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 H. This is two H's. That's called a diprotic acid. But all of these will split. The H will become free. The H ion in the ethanoic acid is over here. Okay? So we'll talk about that. That's that organic acid that we have to take into account. And don't forget your bases are here. So they're not going to yield H plus, they're going to yield OH minus. And just as a little tweak, remember we talked about these indicators and how their color changes. All right, so we always have to have our reference tables at the ready. You can't do chemistry without those reference tables, ladies and gentlemen. Okay. So now what I would like to do is I'm going to stop the video so that these files don't become too big, and we're going to look at acid-base double replacement neutralization reaction.